So, you have a 100 bead Rekenrek. Now what? The 2-row traditional Rekenrek that you might be familiar with does a fantastic job of representing and visualizing values to 20. But you're second grade teachers. Your students are certainly going to be working with and exploring numbers that have values much larger than just 20. And this tool will be a great tool. So before we start, I want us to go over the basics first. So, first things first, white on right. At the top row, the white beads should be on the right. We read a Rekenrek from left to right. So anything that is over on the left-hand side is called in play. This Rekenrek right now is representing 6, the number 6, the 5 red beads plus 1 white bead. So this represents the number 6. The numbers on the right-hand side are called at rest. When you want students to clear their boards, teach them to lift it up, tip it to the right, and then everything is at rest. My other pro tip, the top corner here, put a sticker. Now don't put a sticker like a star that doesn't have a top or a bottom. Put a sticker of, say, a giraffe or an elephant, something that has a clear top and a clear bottom. Put a sticker here so that students will know where's the top, and it will help them to remember white on right so that we don't have this upside down when we're working on it. All right? What we're going to do is we're going to talk about why this is an amazing tool for helping your students to build an understanding of our place value system. By using the 100 bead Rekenrek, we can help our students build their understanding of our base 10 system. They can deepen their understanding of place value, and they'll come to understand the relationships that exist between numbers. And that's what I want you to look for today. I want you to look and see how this really builds a physical and visual understanding of number relationships. All right, so let's start with the basics, counting. We can use the 100 bead Rekenrek for counting. 1, 2, 3, 4, 5. It's great for one-to-one correspondence, but we're talking about second graders. We need our students to begin unitizing. So we want them to be able to do things like 5, 10, 15. Notice how I'm pushing the groups of 5 in one push. I don't want to count out 5 beads and then say 5. And then count up 5 beads and then say 10. We want students to be able to say 5, 10, 15, 20, or 10, 20, 30, 40, be able to count by tens. We want them to see this as a row of 10. We want them to see this as a group of 5. All right, let's clear the board and talk a little bit about place value. So on the Rekenrek, I would have students represent the number 58, encouraging them to count by tens. 20, 30, 40, 50, here's 55, 56, 57, 58. Eventually, if they don't already, they will come to realize that if they leave 2 behind, because 10 less 2 is 8. So here's my 8 in 58. Now I want you to look how powerful this is as a visual model of 58. I have 5 groups of 10. I have 5 tens. And I have 8 additional ones. 8 additional ones. Now these are ones as well. If I have 5 groups of 10, that represents 50. Look at the magnitude of 50. They get an understanding that this 5 does not represent just 5 little beads. It represents 5 rows of beads. And then the 8 in the ones place represents 8 additional ones in addition to the 50 we have. All right, let's clear the board. Let's talk a little bit about even and odd. That's a second grade standard. The Rekenrek can help me to talk about even and odd with my students. It's a larger number. I do not have to worry about the beads rolling all over the place as I'm trying to pair up. I don't have to stick with a small set because I have this contained 100 beads here that I can work with. So in the number 48, let's take a look at the number 48. It's represented here. We've been learning that an even number means that every single one will have a partner. Well, if it's an entire row, I can see that these 5 will partner with these 5. And that will be true for every single row. So if I have a complete row, I know that that row, they all have partners. The 5 reds will partner with the 5 whites. But what about down here? I have these reds and these whites. Can I partner them? Is there a way for me to take this and split it so that they each have a partner? Now, it doesn't have to be the same color bead. It just has to have a partner. Some students might recognize that 8 can be a 4 and a 4. But look how visually strong this is. And I got to use a kinesthetic tool so that I could feel it and touch it and move it. Some students might do this. They might pair them off and go, yep, every single one of them has a partner. And because every one of them has a partner, it's an even number. Let's consider the number 47. How is that different? If we think about the number 47, the complete rows are still partnered. These 5 will partner with this group of 5. They'll partner. It's just these extras that we have to think about. So I have 5 here and 2 here. Well, that definitely doesn't partner up, so let me move one over. So now I have 4 and I have 3. Wait, that's not the same. They don't each have a partner. Let me try moving 4 over here now. So now I have 4 here. Oh, wait, but I don't still have 4 here. Now that's only 3. Do you see how now they're beginning to see this compensation? If I make this one 4, this one's reduced by 1. If I make this one 4 by increasing it by 1, this is reduced by 1. They might also try pairing them off. And what they'll notice, there'll be one guy without a partner. This number is 47. In order for it to be even, every bead must have a partner. Because we have a bead without a partner, we know this number is not even, which is why we call it odd. So this number 47 would be odd because there'll be one bead without a partner. All right, let's talk a little bit about addition and subtraction now. Let's start by representing 21. Think about the number 21. Can you see how visually 21 is 1 more than 20? Now, our adult brains understand that very easily. But for our second graders, this is a concept. By seeing it visually, it will help them. 21 is 1 more than 20. All right, tell me about the number 19. What do you know about the number 19? Yes, 19 is 1 less than 20. Absolutely. Let's look at the number now, 37. Here's 30 because I have 3 groups of 10 and 7 more. There's 5 and 2 more. What can you tell me about the number 37? Many students are going to notice these 3. So 37 is 3 less than 40. Visually, that makes it a very easy concept. They might also notice 37 is 7 more than 30. I want them to understand both of those concepts because when we start talking about addition and subtraction, this will allow them to use what they know about creating tens to add and subtract much more efficiently. All right, so I'm going to pull over 50 and let's talk about the number 50 and decomposing. You're going to notice I'm going to pull in information about decomposing and the commutative property. So with the number 50, we can describe 50 as being 10 and 40. But what if I had 40 and 10? Do I still have 50? This brings in the commutative property. It does not matter if I add the 10 and the 40, or if I add 40 and then 10 more. Both still equal 40. I could also think of it as 30 and 20 more, or maybe 20 and 30 more. Still equals 50. Doesn't matter which way I go with that. So we can begin to talk about commutative property by decomposing these numbers. All right. As many of you know, second grade is a critical grade for building foundations for multiplication. And it starts with repeated addition. So 5, 10, 15. I could have also have represented it as 5, 10, 15. Two of those 5s make a 10, and then one more 5 would make 15. And then I would use the language that I have 3 groups of 5. And it doesn't matter if it looked like this or the other way. I still have 1, 2, 3 groups of 5. 3 groups of 5 will lead into, for next year, when they start talking about 3 times 5. 3 groups of 5. We're able to talk about 5 plus 5 plus 5 means I have 3 groups of 5. So what would 4 groups of 7 look like? There are a lot of ways to represent this. Here's a 7. How would I represent 4 groups of 7? You might have students who represent it this way. Not all of them will, but this would be a very efficient way to do it. And then I know that these 2 groups of 5, this is 10, this is 20, and then I can see that I have 8 white beads. So I have 20 and 8. So 4 groups of 7 must equal 28. Do you see how this is leading to multiplication without us discussing actual multiplication? All right, let's clear this and let's talk about some games, activities that we can play with students. So some of the activities we can do, let's do one. We'll call this one Make My Number. Boys and girls, on your Rekenrek, will you please show me the number 15? Now remember, try to just push over entire rows and groups of beads at one time as best you can. I would like for you to take this 15 and make it 40. Think about how many beads would you need to push over to change 15 into 40. You might be thinking of this equation. I'm going to ask you to write this equation after you're done, but you're going to try it here first so that you can see how many beads you need. And then I want you on your whiteboards to write the equation 15 plus however many beads you needed to equal 40. So students are going to probably recognize that 40 requires 4 rows. Do you see how I can clearly see I needed 10, 20, 25 extra beads to get to the 40? Your students might need more time with this and certainly lots and lots of practice. For Make My Number, stick with groups of 5s and 10s so that they can build their understanding of this in a much easier way so that they will know how to use the tool, because later we're going to do an activity that does not deal with 5s and 10s, and I'll want them to know this. All right, let's talk about groups of 5. Choral counting, incredibly powerful. So let's choral count groups of 5s. Boys and girls, I want you to push, in one push, all of the groups of 5s. Remember, the colors that are all together represent 5, so count with me. 5, 10, stay with me, don't go too fast. 15, 20, 25. I want you to start looking at the pattern that you notice every time we say a number that ends with the word 5, like 25. Look at this configuration. 30, 35, 40, 45, 50. Are you seeing the pattern? 55, 60. We would continue in this way in counting We would discuss the pattern and the relationship of these numbers, that when we say 5, it's not a full row. And when we say a number like 10, 20, 40, 70, full rows. Now we're going to step it up a little bit. How many beads are in play? Yes, 100. Let's now count backwards. If I remove 5, how many are left? 95. 90. How about now? 85. 80. 10, 20, 30, 40, 50, 60, 70, 80. Yep. How about if I remove 5? 75. 70. 65. So the students would be counting with you, in groups of 5s. So we're counting now backwards, but we have a visual representation to help us make sense of it. Right now, what is represented on my Rekenrek? Exactly. Very quickly, without even counting the rows, you probably recognize that this was 50. Because it was half of my 100. I'm building some understanding of the relationships of numbers. All right, let's talk about an activity called Find the Sum. Boys and girls, will you please show 26? 26 on your Rekenrek. All right, hands up. Do not touch your beads yet. I want you to think about some ways that you could add 17 to 26 to find the sum. Don't do it yet. Think about what would be a really great mathematician way to add the number 17 to the 26 I already have. I'd give some thought, some time for them to think, and then we would talk about it. I may have some students who decide they want to push over 10 and then 7 more. So they'd push over 10, and I would say, how do you want to push over the 7 more? Some students might decide to push over 7 more like this. Some students might say, well, let's push over these 4 first, and then I'll need 3 more. Some students may need to count out 1, 2, 3, 4, 5, 6, 7, and push them out that way. But take a look at it. Can you easily see what is the sum of 26 plus 17 now that we've moved the beads? Very quickly, you could see it's 43. Go ahead and do the algorithm, do the math, check it in our adult brains, and let's see if that's not accurate. 26 plus 17 more is 43, but I can see it's 43 just by looking at it. Let's switch that up a little bit. Let's now talk about finding differences. So, boys and girls, will you please start with 72? We're going to start with a lot of them. So here's my 70 plus 2 more. I want you to think about how can you subtract 39. Don't do it yet. How can you subtract 39? I would give lots of think time. I would encourage them to now, if they've come up with a way, come up with a different way. There's more than one way to subtract 39. Some students might say, well, I'm going to subtract 40 and then give you 1 back. Wouldn't that be an amazing way to think of it? Some students might start by counting off these 2, and we'll lead them to understand that that is not going to be the most efficient way. If we're going to subtract 39, let's go ahead and subtract 30 of them first, and then the 9. So these 2, and I need to subtract how many more in addition to that? 7 more. So I can subtract the 2 and 7 more. And when I look at the equation 72, take away 39, I can very easily see it is 33. So 72, take away 39, left me with 33. All right, one last piece. We can use this for story problems. I want you to listen to the story I'm going to tell you, and I want you to make some decisions of how can you use the Rekenrek to help you solve the story problem. All right, you ready? Get your ears on. Let's listen. You want to make 72 cupcakes for a party. You have already made 24 cupcakes. How many more cupcakes do you need to make? So we would go through the process of talking about what this story is about, and then I would give them lots of time to experiment with this. So what I want to make is 72 cupcakes. That's a lot of cupcakes. I have already made 24 cupcakes. Can you think of a way that we can use this tool to help us figure out how many more cupcakes we need to make? And I will leave that right there and let you play and experiment with this with your students. But what I'm hoping that you saw is that the 100 Bead Rekenrek is an amazing tool to help your students visualize and physically manipulate the beads in order to understand the relationships of numbers. And better than that, I don't have all these little pieces going all over the desk. They're attached to the wires. So I'm going to encourage you, find the boxes that have these Rekenreks in them. Pull them out, jump in, and start playing. All right? If you need anything, of course, reach out, but have fun with the Rekenreks.